Okay, today we're going to go through a GCSE IGCSE paper, Edexcel 9-1 IGCSE in physics, which is the same paper that's used in a double award, so it's paper 1. This is a paper I gave my students to do over the spring break, and here are my model answers. Okay, first of all, you need to be aware that the only formula you will be given are the following. So anything not on this list you have to remember. Okay, so we will from time to time show you this equation to show you when they give us an equation that from this list, and other times you'll get marks for remembering the correct equation. The first question is a 5-mark starter with properties of magnetic fields and magnets. Okay, so that's basically what they want you to fill in the blanks. Yeah, so the passage that they've written here describes some of the properties, and you've got to use the words from the box to complete the passage. So I've done that. So really over here you need to know that like poles repel. Okay, so repel is the key word. North pole and north pole repel. So you'll notice that we use north more than once. So if you get one of these questions, unless it says only use each word once, then you can use them more than once. There is attraction between steel and magnets, and that's because steel is the only magnetic material given here. So they've got steel. The other materials are copper and aluminium. Copper and aluminium are not magnetic materials. The only magnetic materials are things that contain iron, like steel, cobalt, and nickel. These are the only 3 magnetic materials. The other thing is, the next bit is about hard and soft materials. Materials that are difficult to magnetize are called hard magnetic materials. A steel is a hard magnetic material, so that's one. Whereas iron is a soft magnetic material, and you need to know the difference between them. So ones which are difficult to magnetize are hard. They make good magnets because once they're magnetized, they're also difficult to demagnetize. Okay, so steel would make a good permanent magnet. The direction of the magnetic field lines for a magnet is always from north to south. Okay, and as we said before, iron is a soft magnetic material, and that means used in electromagnets because you can basically switch them off. The magnets, electromagnets, you can switch them off and switch them on with a current. Okay, remember a current also has a magnetic field. So for this topic, it really revises magnetic materials. There's 3 of them: hard and soft materials, and direction of field lines. And a common question they want you to know is how you will investigate a magnetic field of, say, a bar magnet using a compass. A compass always points from north to south, so that shows what we've spoken about. So you need to know the method of that practical, which I've shown before in previous papers with my students. Okay, so that's question 1. Question 2 is about forces. So this is the first topic of the IGCSE syllabus. So you see the boat is floating on the sea. Here's the surface of the water, the dotted line, and it says the ship floats because of the forces acting on it. So that's balanced forces. So the upward force is given as upthrust. Okay, that's upthrust is due to the weight of fluid displaced. So upthrust is equal to the weight of fluid displaced. So you'll see in this case we have seawater. The seawater is of a certain density. So when the water sinks in this low, this volume of water multiplied by the density, it will weigh more, equal to the amount of the weight of the ship. Okay, so this is an important principle about what upthrust is. So upthrust is an upward force when you displace a certain volume of fluid, and a fluid is anything that can flow. So there's even an upthrust when you're in air, but it's very small because the density of air is very low. They want you to draw another labeled arrow on the diagram to show the other vertical force acting on the ship. So vertical means up and down for those of you studying in a second language. So the other vertical force is weight is pulling it down. That lowers the boat into the water until the weight of fluid displaced equals the weight, and that balances it with its upward force called the upthrust. Okay. Now you'll notice that I've drawn the length of the arrow downwards, yes, about 3.2 centimeters, as being equal to the length of the upthrust arrow upwards. Okay, so you'll get a mark for drawing the weight and labeling it and having it of equal length. So that's how you get your 2 marks. Next thing is state what is meant by the term vector quantity. Well, forces are vector quantities. They told you that. Okay. Well, a vector quantity is a quantity. So vector quantity is one that has. So it's a quantity that has. So it might be better to say a quantity that has size or magnitude and direction. The size of the vector can be represented by the length of the arrow, and the direction of the vector quantity is shown by the direction of the arrow. So anything that can be represented by an arrow, you could say is a vector quantity. So one for understanding each of those 2 features. There's your 2 ticks there. And other examples of vector quantities, when they say give another, you must only give one example. So I've given velocity. But you could also have said acceleration, displacement, which is the vector for distance, and what else? Momentum, for example, which is mass times velocity. These are 3 other examples of vector quantities. So as long as you give one, but don't give more than one. If you give more than one, they will take your first word. Okay? They're not allowed to just look for your answer. Okay, that's question 2A. 2B continues about this, and I'll come back to my diagram in a minute. The upward force is proportional to the pressure difference. Okay, so the upthrust force, I should have said, is proportional to the pressure difference between the bottom of the ship and the surface of the sea. So I've drawn that on my diagram by showing the amount of water displaced here, the shaded area. That's a height difference there, and the pressure difference is given by this equation. Pressure difference is the depth that it sinks in, or the height as they call it, times the density of the liquid, multiplied by the gravitational constant on Earth, which, as you know, is 10 newtons per kilogram. So it is equal to G equals 10 newtons per kilogram, because newtons per kilogram is actually an acceleration. Okay, so that's the G value on Earth, the gravitational field strength. You need to use that. So that's part of the information given to you on your formula sheet. So once you know that is proportional to the pressure difference, yeah, the upward force is caused by the pressure difference. The pressure acting on the ship at the surface of the sea is 100 pascals. So going back to the diagram, above the sea, so there's 2 causes of pressure here in nature. So you've got atmospheric pressure. Let's call it atmospheric pressure, due to the weight of the air pushing on the sea. And then the deeper you go in the sea, the more pressure difference. This will be the pressure, additional pressure. I should have written it better. Additional pressure due to depth of liquid. So, for example, if you go 10 meters down in the sea or diving, then every 10 meters is equal to a whole atmosphere of air, okay, due to the density difference. Okay, so this is revising pressure with you. Okay, so the pressure of the atmosphere is about 100 1,000 pascals. They put it as 100 kilopascals. So the other thing you need to be familiar with is changing things into the SI units, which would be pascals. So when you're reading these questions, you notice I've underlined bits to make sure I've understood what they're talking about, and I add bits of detail, especially in these things, to help you. But you can do this when you're reading the exam. It means you're thinking and you won't miss any specific points that they want you to think about. They want you to first state the formula linking pressure difference. Okay, so pressure difference I put as P, there's pressure difference. Height, density and gravity. So pressure difference is the height times the density times the gravitational field strength. So for example, if the gravity of the Earth was weaker, then the pressure difference due to the fluid would be smaller. Okay, so these are the three factors it depends on: the height in meters, the density in kilograms per meter cubed, and the gravity to convert it from kilograms to newtons is newtons per kilogram, yes, which on Earth is 10. Okay, and the pressure is measured in pascals. So when you put the units in the correct units, when you use meters, kilograms and newtons, then the answer will be in pascals, not in kilopascals. Okay, so here that they've then told you, so we know the equation which I showed you is represented by the depth of the water which the boat sinks to. Okay, so we know the height, obviously they've given us the density, and we know G from our formula sheet. So once we know that, we can calculate it. Well, they're telling us the bottom of the ship is 15.8 below the surface of the sea. So that's H is 15.8 meters. And we want to see if this pressure difference comes out approximately to 260 kilopascals. Remember, you'll work it out in pascals. So how many should be 260,000 pascals? So they've given us the density of the seawater, which is slightly more than water. Water is 1,000, and seawater is, because of the salt, it becomes slightly denser. So you put in the height, which is given to us, the density, which is given to us, and gravity, which comes from the formula sheet, the data sheet. And once you do that, the pressure difference, I just put D for short, pressure difference. I want to make sure that you know this is the pressure difference between two positions. Okay, so it's the height difference, and difference is often shown by this triangle. So the height difference is 15.8, but the boat sinks below, and you worked out, comes out to 162,000 pascals of pressure difference. But remember, we've also got the atmospheric pressure and the pressure difference due to the water. So you've got the pressure due to the atmosphere and the pressure due to the water. Okay, so this is the extra pressure due to 15.8 meters of seawater. Hope that makes sense. So you add the two together, 162,000, etc., plus 100,000 comes out to approximately 262,000, which is approximately 260 kilopascals, which is what they wanted us to know. Okay, so that's how you get your 3 marks. One for putting the numbers in, one for getting the answers, and one for working out that together with the atmosphere that comes up to 260,000. Okay, sorry about that noise, someone is trying to message me. Okay, the next part of the question says, explain why the bottom of the ship is deeper below the surface of the sea. Okay, so now they want you to explain why. So now they want you to understand the reason this happens. Okay, so it's the harder part of science, is explaining things when the ship is fully loaded. So explain why the bottom of the ship is deeper below the surface of the sea when the ship is fully loaded. So when the ship is fully loaded, it weighs more. Okay, so the downward force is greater. So once you realize that the downward force is greater, this pushes, the bits in brackets they're not looking for, but this is showing how well you explain things. So I would put it, this pushes or pulls the ship down deeper into the water, which creates a greater pressure difference, doesn't it? Okay, so it creates a greater pressure difference. So it pulls it down deeper because the weight's greater. So a larger upthrust is needed or created to balance the weight. So they'll give you an extra mark for either of these 2 points. So there's 2 points from these 3 arrow points that I've made. Okay, so as long as you're on the right section, the right ideas, you'll get the marks. And this is question 2, much more difficult, 11 marker. Okay. Question 3 now is about electricity. So question 2 was about forces, which is topic 1. This is topic 2, another very big topic. So the question is about circuits. Which quantity is the rate of flow charge? Well, you should know the rate of flow charge is the current, so it's just a matter of knowing it. The equation which governs current is charge flow per second, where Q is charge. So you need to know this equation. It's not one of the equations given to you on the equation sheet. Okay? And then which quantity is defined as the energy transferred per unit charge passed? Well, that's the voltage. Okay, these are things you just need to know. These are the first 2 things I teach my students when we do electricity: what is current and what is voltage, because these are the 2 fundamental quantities in physics in electricity. And remember, 1 volt is actually 1 joule per coulomb. So the voltage gives the energy to the charge, and the rate at which they flow is called the current. Okay, and what determines the rate at which they flow once you've got a voltage is called the resistance. Okay. I'm just checking the message I received. I apologize. Okay. Okay. So then they're giving you a circuit. Draw. Diagram 1 shows an electric circuit with 2 resistors. Okay. The resistors are R and S. I apologize for that. I'm going to see if I can pause the video.